Okay, hello and welcome back. We're talking about Algebra 2 right now. Make sure I have the paper nice and centered, okay? Talking about Algebra 2, we're talking about exponential growth and decay. This is going to correspond to the first section of our chapter. And so there may be some confusion. Sorry if there's chapter 6 or chapter 7. I mean the same thing. We're talking about exponential and logarithms, exponential and logs in this unit. So it doesn't matter. We're going to switch to more big ideas. Okay, but let's get started. So we talk about growth here. About general shape of the graph is important to understand. So we make sure we can see what I'm writing. Doesn't need to be perfectly drawn here. So I have my x and y table here. Boy, hopefully yours looks straighter than mine. Okay. So let's take a look here at 1. Call this 1. And we have an exponential function coming through. Let's put it as purple. And you'll know this as the shape of whatever life events occurring right now. So this is an exponential growth function. And it makes sense because we're growing exponentially. So we write this equation as f of x equals a times b to the x power. In this case, a is 1, and b we don't know. B equals our growth factor, right? Could be decay, but in this case we know it's growth. A we can think about more generally as our starting value. So we want to define those things. And x equals, this is the exponent in this case. We'll talk about that a little bit more. All right. So notice here that it's impossible for this graph to go negative. Interesting. That's why it's got an asymptote. That's why. So let's define that word here. Let's use green here. So my asymptote, make sure I spell that right. Asymptote is y equals 0. Now, why is it y equals 0? Because no matter what value of x I put in, I'm never going to get a negative value. In fact, let's prove that. We should never, of course, we always want to prove things in here. So let's put down 2 to the negative 5 power. Let's zoom in so you can see what I'm doing. Look over there. So notice here, it's not negative. It's a fraction. It's small. It's getting close to 0, isn't it? Let's try 2 to the negative 10 power. Look, it's still not 0. It's not going below 0, is it? So this is an example of an exponential growth function, right? So I'm just using this example as y equals 2 to the x. And it has an asymptote of y equals 0 because it doesn't matter what x is. I'm never going to get below y equals 0. We can zoom back out. You can see what I'm doing. So if I have this value here, I can't get a negative value, so that's my asymptote. That's my boundary. Notice there's no asymptote here. It's going to go on to infinity if you let it keep growing. All right. So that's my growth function. Let's talk about, of course, its evil twin, or pardon me, it's the other side of the coin, which is decay. Of course, decay is sometimes good. So we'll talk about exponential decay here. If you want to take notes with me, hopefully my xy coordinates don't look as bad as the other one. Okay, and you can imagine here it's actually going to be a mirror image. So it'll look like this. Let me cover that in green so it makes a little more sense as a different. I'm going to separate it from the coordinates. Here we go, and there it is. So this is our growth, this is our decay, and we're saying here that f of x equals we still have the general equation here, see? Now, what makes a decay a decay? We're saying that B is less than 1. And let's juxtapose that to a growth. I forgot to add that note. For growth, it means that B has to be greater than 1. Okay, that's the major difference between growth and decay. We can see that, yep. That's what decay means. And let's start with the asymptote here. Notice the asymptote is still the same, isn't it? Right here. Let me verify that. It looks like it's never going to get below 0. But let's not trust it. Let's give an example. So let's say we had, of course, we know that f of x is the same as y. Let's say we had an example in this graph. We'll call this y equals 1/2 to the x power. You can see that x there, right? Pretend there's an x there. You can see it. Let's see. Is there any way to get a negative? Let's take a look. Let's zoom in. Okay. Is there any way to get a negative value? Let's do 1 divided by 2. That's 1/2. And let's take it to the 20th power. Nope. It's really close to 0, but it doesn't cross 0. Let's just prove this. I'm going to use 0.5, by the way, instead of 1/2. I think you're with me on that. Let's try 25. See, it's still not 0, so my asymptote is y equals 0. Let's zoom back out again. So that's my trick with this. I can derive my asymptote by seeing what value of y does the graph approach but never reach. And over here, notice there's no asymptote because it's going to go on to infinity. Let's show that, though. Again, we don't want to trust me. Let's zoom in here so you can see my work. Let's try 0.5, and let's take it to a negative exponent. You see here, 0.5 to the negative 25 power is getting really big. And you can imagine, let's try 0.5 to the negative 50 power. And it gets really, really big. So that's going to go up and up and up. And so that's our general shape of the graph. All right, that's enough fun with this graph analysis. Let's get to some problems. I'm going to go to 6.1 of the big ideas. Okay, I need some more paper there. We got it right here. Okay. Okay. So, look at some problems. How do we find the graph for this? Well, you should be able to find, if I say y equals 2x, of course, I know by y, I can always use f of x. Just a little reminder. We mean the same thing. How do I find the graph of this? Well, I can make an x and y table, remember? We always start with an x value of 0. Well, when x is 0, y is 2 to the 0 power. That's 1. Okay? When x is 1, y is 2 to the first power. That's 2. How about, let's do another point. When x is 2, y is 2 to the second power. It's 4. And you can imagine what's going on here. Let's try negative 1. Okay? Well, that means y is 2 to the negative 1. That's 1/2. And you can check that in your calculator if you're not sure how I'm getting these values. Then I look and see which graph is very much like this. And it's going to be graph A. This is problem lowercase a. And it's going to match with graph A, graph capital A. That's all. And it looks kind of like, if I were to graph this really fast, this is my 1 point. And let's go here at 1. We're at 2. Make my dots here as I go. We're at 2. We go to 4, right? And here again, this is why, so many people seem to be, 2, 3, 4. Pardon me, yep. Let's go to a 3 as well, just to show it. That's going to get us all the way to 8. Let me get to this point. 3. There we go. And you can see, my apologies, let me just do one more here as well. So you can see why a lot of people missed the event that's been going on. Because remember, it looks linear to the untrained mind, to the uninitiated mind. Oh, it's just linear, don't worry about it. Well, no. It'll eventually start to grow massively if you let it keep going. So that's how to match an equation to a graph. Let's try a decay as well, since we're on this. Let's try letter F here. Let's switch to another color. Let's try letter F. Let me do a little page break here. This is from 6.1, remember, on the big ideas, which I'll give you access to, with the answer key, of course. So we have f of x equals 1/4 to the x power. And we make an x and y table. It doesn't need to be complicated here. When x is 0, y is 1/4 to the 0 power. We know that as 1. Let's try 1 now. That's just going to be 1/4 to the first power. You know that as 1/4. Let's try 2. That's going to be 1/4 squared. And here's where you need to be careful. You have to make sure you're analyzing your work right. Make sure we don't miss my... So that's going to be 1/16. And so it's getting very small very fast. Let's try -2 as well. So it's going to be... If it's -2, it's 1/4 to the -2 power, and that's going to be positive 16. You're going to have to look up, use your calculator. If you need to review that, take a look about why that is. Give me a comment if you want to see a video about why those are, or at least I can answer really quickly. So let's graph this, and we do a quick graph. Let's just do. We know we're at 1. We're over here. That's a good point. We're at 1 here. We're down to 1/4 already. Woo. So that gets small. And at 2, we're almost, let me use another color here to separate things. There you go. Woo. Gets smaller, smaller, smaller. And let's go to the other side now. Let's go to -2. We're going to be all the way up at 16. I wonder if I can even show that. It'll be like up here almost, right? So there's our general shape. This is the shape, of course, we want to see with our current event. We want to see this a decay, but we don't know. So that's it, and I can match this now. If I were matching with letter F, I can easily now go to which one matches it. I just need to look at which ones have the correct answers. Now, it's hard to see sometimes which one matches best. My decays are E, D, and B, and I just need to look at which one it is. Let's try -1 on my chart just to make sure I got the right answer. -1. This becomes a positive 4 here. Pardon me. That's because it's... Can you see that? Yeah, that's because it's 1/4 to the -1 power, which just means 4. So we should be here. That's a 1, 2, 3, 4. So we should be, it's not perfect, my graph, but at -1, we should be at a value of 4, and that's how you can check it out. Which graph is that? That looks like that's graph E. So that'd be my answer there. Okay, that's a little review of just the first section of growth and decay. You should be able to handle those problems I assign, and if not, I'll post some review activities. Notice we've also covered compound interest. That's part of this first section. We can post a review of that a little later. Okay, thank you, Algebra 2. Have a great day.